Interesting. Oh, I recorded my lecture from college. That doesn't matter. All right, so introduction to functional programming. All right, so here are the key objectives for today. All right, we want to understand functional programming principles. All right, we want to be able to define pure functions. I alluded to them last week, and so naturally we'll probably talk about pure functions and the corresponding opposite, the impure functions. Understanding composition over inheritance, and these are like key terms. And then we'll identify functions as objects. So in particular, right, how do we assign a function to a variable? We've seen this already. In your mind, you should have a good grasp of this. You should, in your mind, be able to do something like this right now. Can you assign a function to a variable? And what does that really mean, and what does that really do for us, right? We can pass functions as argument to functions, right? In your mind, can you visualize already like function keyword, some function, it has arguments. Those arguments are going to receive a function, right? We can return functions inside functions. So I have a keyword function called cool, right? With all the bananas, some curly boys, maybe a var or two in there, and then the return statement. And then return will do what? Return another function. And so in your mind, as I'm going through these things, see if you actually understand. And if you don't, that's when it would be a good time to kind of like, hey, I have no idea what you just said. And I'll just try my best to explain it again. All right? We're going to write functions in both the traditional and the arrow syntax. So today I'm going to go over specifically the arrow syntax and the nuances to that. I won't go over everything because arrow functions does some cool stuff with the this keyword, but more just about how to write it and identify it a little bit more familiarly. That didn't work out. Just get more familiar with the arrow syntax. Cool? Great. So first thing is, if you remember, I've said this several times, and that is JavaScript is a multi-paradigm programming language. Does anyone remember what that means or have an idea of what that is? Yeah, that's pretty good. That's pretty good. So a paradigm is simply like a style. Right? Oh, you saw that? Draw the lights down. And so the two main paradigms we're talking about is object-oriented and functional. Really, what the key difference is, object-oriented is exactly what it sounds like. Everything revolves around objects. So have you heard in Ruby the phrase, everything in Ruby is an object? You've heard this, right? Do you understand what that means? Yes? Kind of? Right? Well, let's think about it, right? Let's do this. Let's think about it. Everything in Ruby is an object, meaning if I were to just make a new file called object.rb, it's like a Ruby file, every single thing is an object, right? This thing, what is this? Right? It's the number 1, but it's an object, right? In the same way that I said that if I did 1.4, what is this? It's a float, right? It's a float object. And objects, whenever you have a function that's attached to an object, we call it a method. And this will make more sense here in a little bit, but if you have a method, that means that you can literally call these methods on objects. So for example, .round, right? I'm calling the method round on this float object. Does that make sense? And so everything in Ruby is object. So I can literally put dot whatever method on essentially anything in Ruby because everything in the way it inherits will inherit from something else. Right? String will inherit from like the kernel class, which will inherit from the like object class, which inherits from like the basic object class. Like there's this massive level of inheritance. Everything that you ever do in Ruby will be some subsection of this object. Cool? So if we talk about object-oriented, what we're talking about is anything that has to deal with shared state. Do you remember whenever you built the class? What's the first method you build in this class? Initialize. Initialize, that's right. Very good. Mysterious stranger. It's the initialize class, right? And the initialize the initialized class has instance variables attached to it. What do those instance variables represent in this class, in this blueprint? Right, attributes of the class. Meaning anytime I make a brand new of this object, right, I'll have something like class, I don't know, person. And then I can define initialize. Some arguments. Oops, that's not that. Embarrassing. Some arguments, right? Args. It's going to end. And then you'll have attributes. Right? Let's just say this person works and has like a salary. And salary is what? Do you remember mass assignment where if I pass in a hash, I can call args with the key of salary? It should work. Does this make sense? Did I lose anybody on this? Nice, great, right? So this person makes money and she is balling out of control, right? There's this shared state of salary. So anytime I do person.new, I'm gonna pass in how much money this person makes a year. Cool? So something else that would probably be very helpful is like name, right? And then we'll have like args, the key of name. So we can do something like name is going to be Sally, and the salary is going to be a lot, right? $1 million. I'm not going to count it. This is a lot of money, right? Does everyone understand this so far? So whenever I make a new person, there's this shared state. Every time I do person.new, they will always have a name and salary. And then you can attach methods to it, right? So remember when I said that on a class, if you have a function on here, whenever you have a function inside a class, it's known as a method. So we'll define a new method. It's called getRaise. Cool. And all it's going to do is it's going to take the salary, and that's going to plus equal however much you want to get a raise, right? Like how much raised, and then plus equal how much raised. So every time you run this getRaise method, it'll increase your salary by that amount. So far, so good? Huh? Oh, you're right. My bad. Sorry. Get this raise, right? Thank you. Noise. Cool. Any questions so far? Great. So, does everyone kind of understand this like shared state between objects and this object-oriented programming style? Functional programming, however, is more about like what the code does. What is the behavior of the code? There should not be a relationship in shared state between anything that you do. So, for example, like we have a for each, right? For each is called on an array, and it takes a callback function. If I wanted to do something, let's put this here. If I wanted to do something here, all right, I have my instructors in here, all right, it's just me, Dick Ward, Stephen Balasta, we have, oops, we should not mix and match, Hamza, and we have Ol Zachary. Cool? Questions so far on just this? What I can do is I can capitalize them. I can create a new const, and all it's going to do is be the instructors.map, which takes a callback function. Gets passed in a name, and all I'm going to do is name return to uppercase. Cool? Functional programming is about what your code does. There's no class here. There's no shared state. It's more just about the fact that I'm going to map over and I'm going to capitalize all of these instructor names. And then I'm going to return it, and that's it. Are there any questions on just like the fact that this doesn't really have anything to do with like classes or shared state? It's like this just does something. Great, capitalize this, boom, done. We talked about map, we talked about like pure functions. Does anyone remember what that was?
Pure function doesn't change
That's exactly correct, right? When it comes to a pure function, it doesn't mutate the original data. So if I were to console log capped instructors, and then I were to console log simply instructors, would they be the same? No, because this right here did not mutate the original data. Versus object-oriented. Whenever I run this git raise on, say, I don't know, we have Bob, we have Huzzah back there, and we have Z Money, right? And they all make a lot of money. Whenever I run git raise on any one of these, does that mutate data? Yes, like I can't essentially go back and revert back to their original salary. Their new, right, their new dot salary has been changed. It's been mutated because of this shared state. So far, so good? It's just these concepts. You don't really have to like drill too hard on this. Yes? Okay. Great. So again, object-oriented is like deals with the objects, shared state, typically some mutation of data, whereas functional programming is more about what this does, has pure functions, and does not want to mutate state. Cool? Great. Let's keep going. Functions as first-class objects. We talked about this. What does it mean when a function is a first-class object? Well, it means that functions in that language are treated like any other variable. This is literally the definition straight from the MDN on first-class functions. So, what does it mean to be treated like a variable? It means that I can store it as a variable. So for example, I can have a const eat donut. This is a variable. And I'm assigning it a function. So whenever I reference eat donut, it references the function because objects are passed by reference and not by value. Right. So functions can be passed to other functions as arguments. So here I have a function called is this callback true, taking in a callback. And notice this right here, the callback that I pass in, is this callback invoked right here on this line? No, there are no bananas. But here, it does in fact get invoked. So you should always be passing a reference when passing a callback because inside the higher order function, the callback will get invoked somewhere. And that's where the magic happens. Cool? Now let's take a look. It will get invoked by the higher order function, but it doesn't get invoked immediately. So here, boop, boop, boop. All right, I can have another function that says always true. Cool. Boop, boop. And all it does is return true. So far, so good. If I invoke this function, right, how would I do that? Is callback true? Then I invoke it. And it looks like very explicitly that it needs a callback function. So I can pass in always true here as a reference, as opposed to invoking always true. And so if I were to do that, this is what happens. Is callback true invoked? Therefore, it enters line 13 in the call stack. And then it will invoke this function. Great, let's take a look at what is the callback. The callback here is always true. So always true gets invoked here. And what does it evaluate to? What does it return? It returns true. And so we finish the statement here. If true, which it is, return true. Cool? And so the callback will get invoked inside the higher order function. So far, so good? Awesome. Yeah. Okay, great. Yes, you pass a reference to it, and then inside the higher order function, somewhere the callback will get invoked. Right? And I say somewhere nebulously because you're the one that will define it. Unless you're using a built-in function like a map or each, which you can look at the docs and see where it gets invoked. Cool. Functions can also return other functions, right? So let's take a look at this, as it's important as we're going to reference closures again. I have something called an outer function. This is being stored as a variable, right? And I have inside this outer function variable, inside the function it is being assigned to, is a const called inner variable. And it just says that I'm not a global variable. It's not a global variable because it's being defined inside the scope of the function, right? It's being inside these curly braces. And what it will do is it will return another function where it will simply console log inner variable. Now, I can invoke outer function, right? And if I invoke it, what does the outer function return? It returns this inner function. And that inner function can also be invoked. And so I invoke it twice here. And if I invoke it twice, what does this inner function do when it gets invoked? It simply console logs inner variable. And so the return value, well, not really, what I should see when I invoke outer function twice is outer function gets invoked, which is returning this function, which then just console logs. Something important to note about this, actually. Let's take a look at this. I have a const of inner var here, right? How do I access this const? It's a very weird question, right? How do I access this inner var? Can I do something like outer function dot inner var? Can I do something like this? The answer is no, because this is not a key that is attached to outer var. It is simply a variable that's defined inside the function scope. I cannot access this. Therefore, when I invoke outer function, what does outer function return? What does this return? This returns the inner function. Does the inner function have access to inner var? Yes, it does have access to it, but how do I utilize it, so to speak? I can return it if I want to, right? I can return it if I want to. But can I do something like outer function dot inner var? The answer is no, because inner var, again, is not a key that is attached to this function. It is available in scope to this inner function because it was defined in its outer scope. And so we're going to talk about closures here, right? See how this inner function has access to inner var, but the user outside of here can never access inner var, which means that I've essentially created what is known as a private variable. This is how I do private variables. The interesting thing about it is that everything inside the inner scope will have access to it the way the scope chain works, right? It will see inside this function, is there something defined called inner var? No. Then it will look outside of its scope. Is there something here defined as inner var? Yes. And therefore it will return. I can, in fact, because of scope, do another const inner var here and say inner scoped variable. So what do you think 31 will return? It will, exactly, it'll return line 30 because of the way the scope chain works. The inner scope comes first, right? The way it looks up, and that is here, then it will look here. And const will in fact work here because it is being defined in memory inside the scope of this inner function. So what I'd like to talk about is closure, and that is closure scope is the function and all of its outside variables that are being captured. So when I talk about closure scope, I'm talking about everything that's available between these two curly braces is available to this inner function. So a closure is a combination of the function, of the inner function, and its outside lexical environment. Are there any questions on closures and how to create a private variable? Interestingly enough, if this outer function had some sort of argument here, and I do not pass it in here, nothing is here, right? Nothing is here. Do I have access to argument? The answer is yes, because this exists inside the closure scope. Therefore, the inner function that gets returned will have access to it. Okay? This is very useful when you want to pass your callback functions arguments. Yeah. It'll have access to global.
So you're saying in its outside lexical environment?
It'll always have access to anything outside of its lexical environment.
But it's not scope.
This is the closure scope.
Yeah. So if a variable is defined in the global scope,
It should also have access.
it should,
Mhm.
even though it's not between that closure.
That's correct. The way the scope lookups work. It will look inside, then outside, then outside, then outside, until it gets to global.
Okay, so we have to stop at those.
No, it won't.
Okay.
It doesn't go one extra function out and then goes, I'm tired, I'm done. It'll keep going, right? If there was another nested function, if this also returned another function, right? This will also have access to argument. Cool? Right? It just keeps going up that scope lookup chain. Right? So the idea here is that if I have to pass in a callback that needs arguments, I would return another function so that I can immediately invoke this first one. Let's get into that now as like a small detour since it was relevant to the discussion question this morning, and then we'll continue. So I have a callback function, right? Is callback true? If I wanted to pass in arguments into callback function, right? I want to pass in arguments, right? Let's just say I want to do something like is callback true, and then I have a callback function, and I want to pass in arg1 and arg2. For whatever reason, I need to pass in these arguments, right? I've always told you that it should be a reference to another function. So let's see what this callback function is. Let's name this thing and say this is a function with args. Cool. everyone following me so far?
Yes.
Thank you. And so I'm simply going to say function with args, all right? And this will take an arg and another arg. So far, so good? Just takes in 2 arguments. I don't want to use the same argument names because then it can be confusing, so I'm just going to be a little bit more explicit. And remember, this gets invoked immediately here, right? This is invoked here. So how can I fix that? How can I make it pass in a reference to another argument? I can have logic here, right, where I will take in an arg and like dot each. I'm sorry, dot for. Sorry, I was teaching Ruby. It's hard to jump back and forth. I can do the dot for each here. I can like literally do all my logic here. That's what normally people do. However, we want to be able to pass in a reference. I can just return a function and instead move the logic here. And here's what happens. When this gets invoked, what does it return? It returns a reference to a function. And here, as I've said, has access to these arguments. So in order to do something like this, in order to pass in arguments to a callback, my callback must return a function. This is useful in today's discussion question because if you did not use the onClick HTML attribute, you have to pass in a callback with arguments. The arguments being specifically what div you clicked on in order to process the transitions. So what I would do is I would simply have a function, return another function, and I have access to those divs, the arguments, the e.target in here. Are there any questions on invoking a callback and still being able to trick it into thinking it's a reference to a function so that you can pass in arguments? Great. Yeah?
So is this, like, if you're using the example we were doing with, like, if you called it is callback true with the function with arguments, so you just wanted to return the function like we did with when you had like 1 set of bananas versus 2 sets of bananas? Like you just don't want to invoke the return function right away?
You don't want to invoke it right away because typically if you invoke this function without returning function here, what you normally have is just logic, right? And this will execute on line 25 immediately. It won't actually go into is callback. So for example, let's just take this example, right? If I have logic here, right, that's just simply console log, 7 for fun. What it will do, right, you see how this function is being invoked immediately right here. That means that inside the higher order function of is callback true, it will do this, is callback true, 7. It'll just say 7. It won't even pass it in really as an argument. It'll just invoke, it'll say 7. And then it'll go if, and then it will try to invoke 7. And then it will tell you that 7 is not a function. Does that make sense so far? If I invoke this right now, and I just simply return 7, right? What will happen is this will pass in this as argument. This is being invoked, yes or no? Yes. So it will evaluate to 7. And so naturally, when this gets called, it will Be like, great, I'm passing in 7 as my callback function. If 7, which tries to be invoked, what will happen? JavaScript will throw an error, say, hey, 7 is not an invocable function, and it will break. Which is why we tell you that you must pass in a reference to a function. In order to do that, you can simply return the function and then return 7 or 8. I don't know, right? So here's what happens now. I invoke the higher order function. This gets invoked right here. And what does this return when it's invoked? This function. So then if that function right here, which is going to return 7, so this now is going to return 7, which is kind of truthy, which will then return true. This is how to do that. Did that clarify passing callbacks with arguments? Yeah.
So this is relevant to the fading bugs lab then?
Yes. It's because when you have your event listener, you have to pass in a callback. And that callback probably wants to know what div you just clicked, right? So you'll have to pass it in e.target. And the way you do that is inside your event listener, you simply return another function. So that, even though this function gets returned immediately and you're passing an e.target, it will still be a reference to another function. Yes, you always have a callback in the event listener, correct. They had an HTML attribute called onClick, which is in and of itself a built-in event listener in HTML that passes in that div that you clicked on. But how do you do it without the onClick HTML attribute? How do you do it the way we've shown you, and that is adding an event listener? It must be done something similar to this style. Did that make sense? There are two listeners at that point. If you add an event listener and you also add onClick, yeah, exactly correct. Did that help this morning? For this morning? Okay, great. So let's continue. If there are no other questions. Ruby, as we've talked about, doesn't really have the ability to pass in like functions. It has something close. I'm going to talk about this for literally 2 minutes. Do not memorize this. If you want to get better at Ruby, this is just worth going down the rabbit hole and looking at. But Ruby has something similar, but is not exactly. So I can define a block of code, right? I can call proc.new, proc being the class, new being a new instance of the proc class, and telling it what it is that I want to pass in. And that is a block of code. Proc is simply a block of code. I have var, right? You've seen this kind of syntax before, right? Puts whatever variable I put in. I can call in on an array dot each. If you listen very closely to mod 1, we simply say each map select find will take a block of code. That's what we say. And so I can put this ampersand on P, and this will blockify my code. It's worth running down the rabbit hole. And it runs exactly the same as if I ran dot each, putting in the exact same block, except this time I've stored the block of code as a variable. Proc, however, is not a method. It is not a full function of itself. It's simply a block of code that you can reuse. JavaScript allows the full function to be passed to include like arguments. In this block of code, you cannot store any arguments. And so Ruby is said to not treat its functions as first-class objects. You cannot fully store a method into a variable. And so when I say that JavaScript treats its functions as first-class objects, it's because its functions can be stored entirely inside a variable. You've seen it literally right here. Const capped instruct, actually, this is calling .map. This one, const outer function. It is literally storing an entire function inside the variable of outer function. Arguments and all. Cool. Any questions on just proc? Just a block of code, Ruby can store it. Cool? Great. Let's go into arrow functions. Arrow functions are introduced in ES6, the new modern JavaScript. So if you're looking at JavaScript previous to 2015, it does not exist. And all it is it's a new syntax for defining functions. So you have const arrow, which can also be stored as a variable. So arrow functions are also first-class objects. Here I have the parentheses here, and I do not have any arguments. So I simply just put the bananas. I put this arrow syntax followed by the block. And if I execute it, it just says I'm an arrow function, which makes sense. Are there any questions? If I have these curly brackets, right? What special, amazing word have we just ingrained in our JavaScript programming is missing from here? The return keyword. And it will work as expected, undefined. However, if you're writing one line, there is something called an implicit return in the arrow function. If I write the arrow function, and I write the arrow, and I do not write the curly brackets, and it's on one line, it will implicitly return. I do not have to use the keyword return here. So one line, no curly brackets, implicit return. You've seen this before when we have accidentally jumped ahead and we wrote something like this, dot then, right? And we wrote r arrow function r.json. Hamza went over this yesterday. Oh, almost JavaScript hell. Because this arrow function is one line, there are no curly brackets and no return of r.json, right? So if it's one line, no curly brackets, implicit return. Are there any questions on that? Yeah?
The lack on, or preview rather, on arrow functions was really sort of confusing.
Okay.
There's one section in the middle where it seems to state that using brackets will only work for a single line function, and you should use parentheses instead. That's clearly not what we see.
Can you link me the lab later and we'll talk offline? Sure. That sounds very bizarre. It's worth looking into. Thank you for bringing that up. Cool. Yeah, definitely want to omit the block on a single line, implicit return. Are there any other questions on that? Great. Now, it will not work if you have multi-lines, right? It will not work if you have multi-lines. Are there any questions? You see how this right here does not have the curly brackets. It will throw a syntax error. Multi-line arrow functions require this block, this curly boy syntax. Are there any questions? Yeah.
When would you use the parentheses instead of curly brackets?
Never. Like, this is wrong. It's syntax error.
Right. Right.
You would write it when you're trying to show someone this is the wrong way to write. Meta. Good question. Good question. Awesome. Great. Now let's talk about ifs, right? This is a common thing in JavaScript. It's called immediately invoked function expression. Immediately invoked function expression. What do you think that means? It means, huh? No, you're good. You want to try it? Or?
No.
Okay. Great. It just means that your function is immediately invoked. We're not trying to trick you, you know? And that is just simply iffy val, right? Iffy val, right? I wrap my entire function in parentheses. And so this whole thing is a function wrapped in parentheses. Does that make sense so far? And then I put, oh, what's that? Wow. The bananas. Which means that I'm going to invoke this function literally as I define it. As this function expression is being written, once it is done, I invoke it immediately. Cool? It's immediately invoked. So, what do you think const iffy val is? What is the value of the iffy val? It's the evaluated function. So, if I were to do something like this, right? What you see how literally as I pressed enter, it console logged. Console logged immediately. I am invoking the function already. So what is iffy val? It is the return value of the immediately invoked function. We talked about this just earlier when we talked about closures and passing in callbacks and why we want to always pass a reference in the callback, because if you invoke the function, it will evaluate at that exact time. So what does this function return? This function returns high. And if it's being invoked and it returns high, I am simply storing high inside the iffy. Are there any questions about that? Yeah?
Will we just understand later on when we might want to use this versus saying if you val bananas?
Bananas? Oh, right.
The only difference I'm seeing is that we don't have to put bananas after.
Right, so you're saying like if there was another const called iffy, I guess, just put not iffy. Yeah, whatever, we'll just write it like that, right? Not iffy. And it is not immediately invoked, and it just returns. Let's just make it do exactly the same thing, right? Let's make it console log, right? Not immediately invoked. And then it's going to return by Felicia. No, I'm just kidding, just by. Cool. Oh man, that's embarrassing. Do you guys know what I did? Yeah, thank you. No, constant iffy 2. Right, you'll see me do this a lot. It's a function. Ooh, embarrassing. Cool. Great. Notice how it did not console log when I hit enter. However, this one console logged immediately when I hit enter, right? Because it's being invoked immediately. So what you're saying is, what is the difference between this and then adding the extra parentheses later? Well, not iffy, right, is a reference to a function. It's not the actual return value, which is high. And I can invoke it, which will then console log and then do by. Notice how iffy, again, is still a reference to a function. It is not the stored value of by. Versus iffy val is the stored value of high. It is not a reference to a function, no. Yeah.
I guess that kind of answers my question as to why it doesn't console log again.
Why it doesn't console? Because it's just a reference to a function. All right, cool. This always takes a long time for people to wrap their heads around. Cool. So remember we talked about these functional programming principles, often abbreviated as FP. So naturally, right, object-oriented, what have you seen that abbreviated to? OO, right? So if I talked about OO, object-oriented JavaScript, naturally if you see the acronym OOJS. Will that make sense to you? Can you at least infer what OOJS just means? Object-oriented JavaScript. Cool. Right. Remember, functional programming is pure functions, and that is something that does not mutate your original data. It avoids shared state. It does not mutate your data, and does not do something known as side effects. I'm going to go over what side effects are, but just understand that this is sort of the definition, right? Functional programming is declarative rather than imperative. And so imperative programming has more to do with how to do things, right? A series of tasks and operations, versus declarative programming has more to do with what a program needs to accomplish without specifying how a task should be completed. So I talk about this all the time, right? In regards to, great, I want to submit this form, and when the user submits, I am going to see the comment that the user submitted in this form. This is very declarative in the sense that, what do I ask you guys to tell me? What information do I need? Well, I need to know the input. I need to listen for the submit, right? So what the program needs to accomplish, it needs to grab the input, it needs to listen to the submit, and then it's going to do something once the user submits and clicks the button with what it is, right? How you'll start to see as you kind of break it down separately, right? Imperative, naturally, if it's not functional, it's then therefore more object-oriented, and you'll start to see all the little steps that are involved, and you'll start to see classes with a lot of different methods, method chaining. This is more like how something is done. This takes a really long time to kind of understand. So just in your mind, just separate how something is done versus what needs to be done. That's really kind of just the gist of it. Cool? So, pure functions. There is absolutely a return value. There are no side effects. Again, I'm going to go over that here in a second. And if you put in the exact same input, it will always return the exact same output. So just given this exact sentence, what can you say about the reliability of a pure function? What is it, super reliable or not at all reliable? Super reliable, right? In the same way that impure functions, right, mutate state. They mutate state. Impure functions will mutate state. So for example, if I were to run .getRaise on this object, every single time I run it, I'm passing in the same instance of person, but is the value different every time? Yeah, it should be. I mean, that person's getting a raise. Like, hopefully, like, if I put in person 1, I give them a raise, and then I put in person 1 again and give that person another raise, it doesn't return the same value. That value is mutated, and therefore it is impure. Are there any questions on pure and impure functions? Ooh, you heard that? Spicy. My back. Cool. So we talked about this, right? Capitalizing. Is this in your mind as we read through it? Just think, is this pure or impure? I'm going to have a const called capitalized name. It is simply a function that takes in a names array, right? Like Hamza, Zach, your boy, right? What it will do is it will create a brand new array. It will loop through the names array. It'll iterate through each one and simply push into this brand new array object. For each one, it will run a method called toUpperCase, and then it will return this brand new array that I created within this const. Does this count as a pure or impure function? Who says pure function? Very good, yes. Impure function? Smart. And it's because the original names array was not mutated here. right? It created a brand new array and then simply returned a new array. Cool. So smart. All right, let's do, no, this is also pure. Crud. All right, that's fine. So we want to avoid shared state, all right? So shared state is any variable, object, or memory space that exists in a shared scope. We see this right here, right? They all share this @name attribute, this @name salary. It's all within the same scope of this person class. A shared scope can include global or closure scopes, and often in object-oriented programming, objects are shared between scopes by adding properties to other objects, right? So I'm literally adding properties to this person object. That's exactly what that means. So you're going to be using, in order to avoid it, you have to use immutable data structures, which makes sense because I don't want to be able to change my data. I want to be able to do something to it and return a copy of it that is now changed so that my original data is still the same. I did not mutate my original data. Cool? All right. Mutable data, right? An immutable object is an object that cannot be modified after it is created. So you see this link right here, Master the JS Interview. What is functional programming? This is a link. Mastering the JS Interview is like a read. If you have time over the weekends, at night, like read some of these links, right? The readmes are pretty money. So let's take a look at this, right? I have a const of destructively mutate. Should be a pretty indicative hint. And it takes in a numbers array, like nums. And what it will do is it will loop through them and simply take the exact same numbers array at each of the indexes and increment them, and then return the original array after I had changed it. Is this pure or impure? Who says pure? Who says impure? Purity low, right? Purity mad low. Cool. Great. That's really about it. We'll talk about prototyping and object inheritance later. There's something called freeze, and that will like completely lock your object. Ruby has the same thing. We don't use this very often, but just know that you can call object.freeze, passing in an object, and then if you add an extra key like restaurant, this borrows authentic New York pizza, it will not throw an error. It won't even say anything to you. And then when you console log frozen pizza again, it will be the absolute original value. There's like literally no mutation happening here. Cool? That is like the hard immutable object. Cool. I said I'd get to side effects, and here we are. A side effect is anytime the application state changes outside of that function. So, for example, fetch. Fetch. Inside that function of fetch, and even in the .then, does anything happen outside of the fetch? Which sounds like a weird question, right? But I want you to think about it. What does fetch do? It makes a network request, right? So, and it gathers data. Sometimes it posts, it creates data. Sometimes it will patch and update data in the database. So inside the fetch itself, the function fetch, did anything else change outside of that function? Kind of weird, but when I ask you, is the database sort of housed inside the fetch statement? No. But did the database change from the fetch function? Yes. So this is known as like a side effect, right? And what that means is, if something happens outside the function, it is a side effect. So console log, when I write a function and all it does is console log, what do you see after the log? After you see the function being executed? Right. It logs whatever value I wrote. That log is literally writing to my console, and I will see it. So that log to the console is an effect that happens outside of the function versus something like, I don't know, something like this, where if I invoke outer function and it returns this function, did anything happen outside of outer function? Not really, right? So the idea is that side effects are something that happens outside the function. So logging to the console. When you manipulate the DOM, when you have a function that does append child, did something happen outside the function? Yes, it literally changed the HTML, literally changed the DOM that the user will see. This is a side effect. So writing to the screen, writing to a file, writing to the network, fetch requests, right? When you trigger any external process, is a side effect. Are there any questions on like side effects? Awesome. Cool. So side effects, right? Would you say that side effects are like a pure or impure thing? If you had to kind of like guess it. Impure, right? So do you think side effects are something that should be a part of functional programming? Like no, right? And so the idea is, how do we have something happen in a purely functional programming paradigm? How do you actually get from point A to B if I can't ever mutate any data, I can't have any side effects? The idea is composition, and that is I'm going to combine multiple pure functions and then ultimately receive a different result. So for example, does anyone know what a URL slug is? All right, so the idea of a URL slug is simply, I'm just going to go to Google and I'm going to look up Sbarro's. Super hungry. And notice how like it just says Sbarro's up here, right? I can look up Sbarro's coupons and, oh, did not expect that to happen, but I see Sbarro's plus coupons. Did I put plus in here? No. So a URL slug is simply like a function that takes a string and will change it to another string that I can utilize in like my URL. Because the URL doesn't like spaces. So I have to like mutate it somehow. So that being said, there's a way, right? Let's just say I wanted to search for something like Pizza Hut. The idea here is I want to change like Pizza Hut, whatever I put in, to this like underscore all lowercase Pizza Hut. So I can combine multiple functions and simply, first I'm going to take a string, right, like Pizza Hut, and I'm just going to lowercase it. I'm going to store it in a variable called lowercase string. And then there's another function that simply replaces any open spaces with like an underscore. So what I can do is have this URL slug take in a string, and it will invoke lowercase string. And the return value of this invoke lowercase string is going to be used as an argument for sub underscore. And so now if I put in Pizza Hut and I pass it into URL slug, right here, Pizza Hut, I should see something like this. Right? These are pure functions because lowercase string takes in a string and returns a copy of that string lowercase. So my original string, did that change in value? My original string? No. Yeah.
Doesn't this, it makes sense to me that you're not changing the original data, but let's say you have like obviously a huge website with tons of data, but you're never messing with the original data. Doesn't that, like, when you have like problems with network, I mean, you're talking about like essentially you're storing copies of the original data that's new data.
Yep.
So doesn't that cause issues with memory?
Yeah, you would get this idea that eventually if I keep making copies of everything, I'm getting really convoluted in like how much memory I'm using. the technology and the algorithms that happen in the background in the browsers, it is a function known as garbage collection. And that is when you no longer need something, under the hood, your computer programs will literally delete and throw away the memory that it used to save space for new memory, for like new things. So for example, if I ever refresh a page, do I need to store all the things from the previous page? No, I probably just need only the URL from the last one. So that if I ever hit back, all I have to do is make a new GET request to that URL from the back button. And then boom, new data. So the garbage collection is really efficient on the internet, especially in the browser. And you won't have to really consider that as web developers. As software engineers, as you're building code for actual applications that deal with like hardware, that becomes significantly more relevant. And you have to be careful how much memory space you actually wind up using. And then that ties into another conversation about something called Big O. Have you heard of Big O? Big O, yes, Big O, yes, no. Big O is the idea behind computer science that everything you do will take a certain amount of space, right, like memory space, and will take a certain amount of time. And that's all. So like I can have a function, right, and this all it does is it goes through each letter, and if it's capitalized, lowercase. If it's not capitalized, do nothing, right? There's a certain speed complexity to that. If you write nested for loops, right, you have like a for loop, and then inside here you have another nested for loop. And then this becomes not I, but J. Then you have I and J running at the same time. You can imagine this is much slower because in order to get through every single item in the array, I have to do something else with that item. And so to answer your question, this can start to take up a lot of space, but for web developers, it is not a massive priority, although it is a factor. And that becomes much more into computer science and something past the level of this lecture. If you wanted to learn more about it, look up garbage collection and Big O notation. Cool. That's a very good question. Sweet. So, any questions on how to kind of like actually do something with the functional programming paradigm? The idea here is that, as I said earlier, JavaScript is a multi-paradigm language. So while you want to keep as many things as pure as possible, your app would do nothing if you never mutated state. So the idea is trying to block off as many pure functions as possible so that those blocks of code are really reliable. And you want one, maybe two functions to mutate state so that when your app works and then you change some data and then it breaks, you don't have to look through your entire app. You only have to look at the two functions that mutated the data. Because if you do your pure functions correctly, same input, exact same output. Does that help with like code organization and thinking through like JavaScript? Cool. So that's composition, right? Essentially just method chaining. All right. There is one more thing I wanted to go over, and that is this. What we can have is, we can have something called factories. And that is I have a robot factory, and all it is a function, it's arrow function. And notice that it's being wrapped in these parentheses right here. Being wrapped in these parentheses right here. So this one matches with this one. And all I have is an arrow function, standard arrow function. And that will declare a variable. It will return another function, which takes arguments. And this function returns an object. So what you can think about here is this robot factory function declares one variable and returns another function. It is then immediately invoked. So let's take a look at that. This is immediately invoked. So far, so good. This whole thing is immediately invoked. This whole thing is immediately invoked. So far, so good. So when I see robot factory, just robot factory, what is the value of robot factory here? Who said that? Actually, it doesn't matter. That is correct. I don't want to like target people, right? It's intimidating, I guess. You guys are laughing. I feel so bad. It's the function, right? Because remember, this whole thing is immediately invoked, which means that robot factory is actually the return value, which is a function. And that function takes 3 arguments. So naturally, I'm going to pass in 3 arguments to robot factory. But what happens to this total nums robot created? Where does it go? What happens to it? It is stored in memory inside this function. This is the importance of closure. I never have access to this outside. A user cannot, or a developer cannot do robot factory dot total nums created or access this variable somehow. As we alluded to earlier in closures, this is a private variable. So if I were to invoke this function with 3 arguments, what do you think I would get? The return value, which is going to be a brand new object. So let's do that. It doesn't really matter. Let's do this. Okay, interesting that Google threw an error. Cool. So far, so good. So what is robot factory? It is simply the return function. Right? Remember, total num robots, private variable, gone, lost it. So what happens when I invoke robot factory, which is this function here? Well, what is T2000? It's an object. Right? Interesting. Where did ID come from? Total num robots created. We talked about closure, we talked about scope. So total num robots created actually has access to this variable. And at this point was 1. And then it incremented. Meaning the next time I call total num robots created, what should I get? Great. So if I were to do something like, I don't know, invoke robot factory again with a T3000 and it not being Terminator, but does anyone have like a favorite robot? Wall-E. And does Wall-E have blinking lights? Oh, okay, cool. And what would you say the microprocessor on Wall-E is? Just regular. Just regular. Cool. So what is T3000? ID2 with these attributes. Does everyone understand how the ID got incremented? Even though the function itself is referencing a variable. I wish I had my pointer. Is referencing a variable that I no longer actually have access to outside. This is the power of closure and how to actually create this private variable. Yeah.
Would the ID change if the pluses were on the inside of total number of robots created?
Yeah, that's why I started ID at 1. Otherwise, what you're saying is like you put it plus plus here. Why not put it here?
Right.
It's because I started at 1. If I started at 0, I would put the plus plus beforehand because then it evaluates, right? Which here, either way, it's more like a stylistic thing.
But like with the toy lab, I know that kind of caused me an issue with putting it on the outside. It wouldn't increase the likes on the actual object, where it wouldn't save in the database because it was on the outside.
Correct. But every time you clicked afterwards, it would go up. So on that first click, it doesn't really go up, but on the second, third, fourth click, it goes up. Right. I'd put the plus plus beforehand. Smart.
Is this like considered a side effect because you're changing total number of robots created?
What do you think?
Yeah, because that's an actual function, but it's still in scope.
Who thinks that it has a side effect? Well, let's take a look at the side effects again. Cool. and this is important to kind of like think through, right? A side effect is any application state change that is observable outside the function other than its return value.
It's like a function in a function, right? And
Mhm.
that first one is not in that second function, and it's still changing it.
Would you say the state changed on the object that is observable outside the function call?
Is it because it's not observable after the function call? That's like,
It is observable outside the function call. I would say that this is, in fact, a side effect. Yeah. Because every time you call it, right, your ID is going up, and inside the function that you're looking at, you can't really see it. So something is happening outside the inside function, and it's mutating data. I would consider this a side effect. Cool? Great discussion. But the idea is to think through, right?
As I said, just to add to what you're saying, like with pure functions, it's like if you have the same inputs, right, the output should always be the same.
Yeah.
In this case, like you could input the same exact thing for this object, and the output would technically be different because of the ID.
Yeah, so for example, right, to Hamza's very good point, if I were to make T2001 and I put in the exact same information, I would get a different return value. That's actually the better point. Thank you for that. What I said was like dictionary definition and convoluted. But yeah, if you just follow the idea that with the exact same inputs, it should have the exact same outputs. And here, we don't. Because something outside the inner function, which is what we're invoking, has changed and mutated. Smart. What a good class. Cool. If there's no other questions, that's all I have for you today.